We picked the theme farming in a tight year because 2022 saw significant cost increases in production inputs, labor costs, combined with global supply chain issues. Agriculture production is becoming very challenging. We put this webinar together in order to evaluate some of the products and processes that we do on farm, and it means to streamline and hone some of these operations. So to get us started on the right foot when planning trials on farm, here's Caitlin Congdon.
All right, hello everyone. So to get the bulk of the presentation started here, how do on-farm plots fit with our theme? Well, Sunny mentioned it right there. It's, you're making decisions on your farms every day about, which varieties to use or which products to invest in. And all of those tie into the efficiency of your farm and the bottom line as well. So we just wanted to talk a little bit about how to properly approach doing an on-farm trial and how that's going to help you be able to gather some information to make some of those decisions on where to invest and what to use on the farm. So the first thing you want to know when you're approaching an on-farm trial is, what do you want to find out? Do you want to test a new product? It could be a pesticide or a fertilizer product or a biostimulant, or, there's a lot of products out there on the market right now. And this is a good way to try one and find if it's going to do what you want and if it's worth it for you. It could be testing a new practice. So maybe a new tillage type, if you're looking at going from a more conventional tillage system, maybe doing strip till or something like that. This could be a way to look at it. Or if you're interested in integrating cover cropping into your practice. It's also a way to fine tune the practices that you're already doing. So that could be things like honing in on the right fertilizer rate for your field or your farm, and or maybe the right plant population or seeding rate. The key here is that you want to choose one yes or no type question. It's really easy to get bogged down in the details and looking at too many factors at once. So it's best to keep it really as simple as possible. You should also have an idea of what might happen when you're doing this trial, so a hypothesis. And then the data that you collect would either support or reject that hypothesis. So for instance, if your question is, can I lower my soybean seeding rate without losing a large amount of yield? Your hypothesis could be, I can reduce my soybean seeding rate by 20,000 seeds per acre without significantly impacting my yield. And then the data that you collect will either prove or disprove that hypothesis. So once you have a question, you want to decide what data is important. So those could be very simple things like yield. Did it increase? Did it decrease? Or did it stay the same? Because that's also an answer. It could be things like quality. So marketability, what percentage of the crop is marketable? It could be size. So for something like apples, is it the right size that you're looking for your market? For grains, it could be test weight. And if you're looking at feeding something like to your livestock, you could be looking at nutrient value. The most important one is going to be your economics and your return on investment. Was it worth it to change that practice or that product on your farm? Some things that you want to keep in mind when you're deciding which data you want to collect includes, is it practical? Harvest time especially is a very, very busy time, and you don't want to have something that's going to take a lot of extra time and a lot of extra steps, because if it is, it's probably not going to get done, or it's probably not going to get done well. And if you're going to put the effort into doing an on-farm trial, you really want to make sure that you get quality data out of it. Other things to think about, is there any other technology or equipment that you might need? So that could be things like sensors or a weigh wagon or things like that, that are going to allow you to collect the data. Do you need to send anything away for testing? If so, you should identify right off the bat where it needs to be sent and any costs associated with that. And then next, we want to look at what form the data is going to take. So numerical form, that's, you know, just your numbers, your yields, maybe it's a stand count, or maybe it's a comparison, like the treated plot had 50% more or less something. The other big category is visual observations, and those could be things like overall plant health, or if it's cover crop, maybe soil coverage. And the tricky thing with visual observations is that they can be really subjective. So it's nice to be able to, if you can, take something that would be a visual observation like soil coverage and be able to convert that to a numerical value. So putting using a certain area and putting a percentage on it. And that's going to allow you to kind of have a more concrete set of data to be able to deal with, and also allow you to do statistics with it, which is a really important thing that we're going to get into later. And then lastly, your economic data and return on investment. You're on mute there, Sunny.
Thank you. So you really need replication when you're running a trial. Without replication, what you really have is a strip trial or a demo plot. And those things are valuable as well. But if we can't do replication, we can't do statistics on the data that we're generating, and we don't know if the result that we're getting is from chance or if it's truly a result of the treatment that we're applying to those plots. So replication is utmost important. It allows you to do statistics at the end of the day that's going to show you if your results are true to the treatment or just random chance. So when we want to do replication, we also have to do randomization. So randomization is when we randomly put our treatments across our plot area, and in doing so, we don't favor one treatment over the other. So next slide. This is just a representation of soil across a field. We know in Nova Scotia that soils can be quite variable from one end of the field to the other. So because we have a variability in our soils, this automatically means that we're going to have variability in our plots, right? So is the result a question of the variability within that plot, or is it a result of the treatment is really the question we're trying to answer. So we know that there's variability out there. How do we deal with that, and how do we minimize that, right? So when we're putting our plots out on the field, we want to pick a field that is very uniform in order to decrease that variability. If we have too much variability in our numbers, in the data that we're creating, we're not going to have a very strong relationship between the results we're finding and the outcomes of that trial. So on the next slide, what we see here is that same field again, but this time we're measuring EC across that field. So we've had a SWOT map or something like that made of that field, and we can visually represent the variability across that field. We can select the most uniform corner of that field in order to put our replicated trial now. So we can use something like this or a yield map, or we can simply consult the farmer to see where we should put that trial on the landscape so that we minimize variability and have very tight numbers at the end of the day. So next slide. So sometimes variability works in our favor. This is a trial that was done in small plot trial. On the left-hand side, we can see that there's quite a bit of variability. This is actually an NDVI image of the plot area. And on the left-hand side, there's a bit of a sandy eroded knoll that came through the plot area. And we can see that some of the corn hybrids that were planted across this area in a plot fashion, some of them didn't do very well during that dry period. And the NDVI showing up in red indicates that the plant health is very poor for some of these hybrids. They're not able to withstand those dry conditions. Some of them are showing up quite green, so that's showing that they have good plant health. So in this way, we're able to select hybrids that may be able to take drought conditions better than other hybrids. So just on the next slide, we could see that if we have to plant a sandier field, some of these hybrids might be better adapted to take those sandier, drier conditions than others. Of course, we have to back this up with yield data at the end of the day. These hybrids, maybe preserving their own health at the cost of yield, much like a fat Holstein cow would. Is she keeping that energy for self-preservation, or is she putting it into maximum milk production, or in this case, a maximum grain production? So in this case, it's not a total loss because we have a variability across this trial. We can take some very important takeaways from this trial, but the trial as a whole, the data coming off this trial is going to be highly variable because of the variability in our soil type in this case. Next slide. So the next thing we want to think about is traffic flow. In a field crop situation, the ideal thing would be to have treatments over your tram lines. And if you can see the picture on the left there, probably what you want to do is make 2 passes while applying your treatment. And then you can run your combine down through the middle between your tram lines and be unaffected by your tire tracks. So in that way, you want to match up your equipment widths where possible. And you got to think about your sprayer, your spreader, your combine, and the number of rows you're going to be covering in a hort crop. And even if your spread pattern is indeed even enough that you can pick up a difference in the treatments. The next slide, Caitlin. Nobody thinks their field looks like this, but I put this in there as a bit of a joke. Oftentimes when you roll in with your combine header, and combine headers are getting wider all the time, and the field doesn't look like you imagined it or what you remember from when you're putting your treatments on. And now you have a 36-foot wide header, and you're trying to decide at the end of the trial, when you have all your time into it, where exactly you're going to harvest and take good yield data. So you don't want to be in that kind of a situation. Next slide. So before you get going in the off season, you may want to sit down and just draw out your widths of all your pieces of equipment that are going to go over that plot area, and how you're going to apply your treatment, so that when you land in there with your harvest equipment, there's no surprises for you. Next slide.
All right. So once you have your trial kind of formulated, it's really important to make a treatment map. So you may not be the only person going into that field, whether it's for the treatment that you're interested in looking at, or if it's just, your regular maintenance. So you want to have a map so that everybody who's going to be in that field knows what's going on. Maybe they know which areas they need to avoid, things like that. So a few components of a good treatment map would be the field ID, whatever you want to call that, and the treated area versus untreated area, some landmarks for orientation. So that could be a tree line or a roadway or whatever. And then row numbers or varieties if you have different varieties in one block. So I've included a couple of different treatment maps here, and it just shows that they can be very simple or a little bit more complicated. So one other thing about creating a treatment map, and it's going to lead me into my next point of identifying the treatments, is you want to really think about, you're doing this probably early in the season. Maybe it's right after planting, or whenever you planted there is nice and small. But if you're going to wait and collect harvest data off of that, then your crop's probably going to grow a lot before that point. And the small markers that you put in at the time of planting may not be visible anymore. So one thing that we like to do is, if you're in, say, a cornfield or something like that, you're going to put your flags in off the headland, because that's probably where you're going to be collecting your data, and then just follow a straight line out to the edge of the field and put another flag in there. And that one is going to be visible throughout the season. You're going to be able to find that flag and know that you just have to follow it straight in from there, and to be able to find your flags at the treatments again, since otherwise it's just a jungle. You may never find your flags again until after the combine's gone by, and then it's too late to collect your data. Yeah, so identifying the treatments, there's a lot of different ways to do that, and it all depends on what kind of a crop you're in. So it could be flagging tape wrapped around the trunk of a tree, or little stakes and labels that you put right in the ground, or this the middle picture, I guess you can see here, is it was a stake, and then we put an extra flag on top of it just to make it a little bit more visible. And this was actually right at harvest time, so that was kind of a marker for the combine driver to kind of aim for. Some other things you want to take note of would be the date of planting, or the treatment application, whatever that is, application rate or seeding rate, and then harvest date, and any weather conditions or special circumstances that took place around those treatments. And that will just help at the end. You might want to look back and try to explain why the data is what it is. And if you have all those things written down, then that might help kind of tell the whole story. So this next section that we're going to do is just a couple of scenarios, real life scenarios, I guess, of some on-farm trials that you could possibly do. And Sunny, I will let you take it away with that.
Yeah, so in this next section, we wanted to introduce some trials and go through the process of how we would set them up. And first thing that Caitlin mentioned was you got to keep your trial simple, right? You're doing it on farm. You have limited application equipment. You have a lot of constraints on your time and your equipment. And at the end of the day, you're just trying to answer a simple question, right? So what I've thrown up here first is a couple trials that I don't think would be suitable for performing on farm. So this first one, angular leaf spot in strawberries. First thing you do is you take a look at the number of treatments you have there, and right away you know that this is going to be a fairly complicated trial. When you're dealing with diseases too, a lot of times your infection can be very sporadic, right? You don't have the infection taking place across the field as a whole, it can be very spotty. So the chances of you having even infection across your plots are very limited. So in this case, you know, in order to set yourself up for success, you probably want to grow a susceptible variety. You want to have high humidity in that field. So maybe you want a field that's a little bit smaller with a tree row around it to get that humidity up a little bit higher. Maybe you want splashing in that field to get your disease taking off. And so maybe you want the overhead irrigation on this trial. And if you're looking for small differences, maybe you want to increase the number of reps, right? So we have more reps. We have more chance of finding disease in every plot. So right away that this trial is getting a little bit too complicated to be done on farm. Too many treatments, uneven infection, perhaps it's better off left to small plot trials, and it can be done off-site with a susceptible variety that maybe the farmer doesn't want to grow anyway, right? Next slide, Caitlin. Another scenario here, cyclamite on strawberries. Again, quite a list of treatments. You're going to want a susceptible variety, too many treatments, uneven infection. Perhaps again, this one is better left to small plot work by dedicated staff. The other thing about this one is the outcome is that you're going to want to measure is cyclamite infection, right? So that's very tedious with a microscope. What farmer is really going to want to spend their time to do that anyway, right? So better off left to somebody that's dedicated to that trial. Next slide there. In this trial, we're looking at foliar calcium on strawberries. And so, okay, maybe this is doable. We could have 3 treatments, 2 calcium products, and an untreated check. Of course, we want that untreated check because we're comparing these calcium products to no calcium at all. So 3 applications, oftentimes when we're applying a calcium product, we do it at different growth stages and repetitively in order to get enough calcium into that fruit to make the difference. So we want to do 3 applications from fruit set to red fruit. Okay, so maybe we could do this trial because we're spraying through that period anyway. With our fungicides, we can just add this to the tank. Very easy, manageable trial to do. So we want to flesh this out a little bit more and say, you know, what would we record if we wanted to do this trial? And there's a number of things we can record. You can call those key performance indicators or what we want to measure, right? So we can measure the firmness of the fruit, or we can simply look in the box and say, does the fruit leak? Or do I have redness on my fingers when I harvest that plot? We can look at the shelf life. So we're putting calcium on to make a harder berry. Do those harder berries have a longer shelf life? We could pick 20 berries from each plot, put them in the fridge, and see how many are marketable after 10 days. So in that way, we're generating numerical data, hard data, that we can later crunch the numbers on, do some statistics. We can look at yield. When it comes to yield, we can harvest the yield from the whole treatment area, from the whole plot, or we can measure off 10 feet of row from each plot and just harvest the fruit in that smaller area. So it's much easier for us to manage. We could do taste. Now, taste is very perceptive. You may not be able to, of course, do statistics unless you related that to some kind of number, but it's something you may want to collect notes on across the trial area. One of the products had silicone in it as well. Silicone, depending on the literature, it has some effect on fungal diseases. So maybe we want to do ratings on powdery mildew. So we can look at each plot, give them a rating of 1 to 10 based on what we see for powdery mildew infection in that plot. So these are all things that we can easily measure and is doable on farm. So far our trial's coming together in the planning stages. The next thing we want to think about is how are we going to do this? Like, it's easy to sit here in the middle of winter, snow on the ground outside, and come up with all kinds of plans, but we have to make those plans very practical, very easy to do, because time is quite a precious commodity in the heat of cropping season. So we'll just skip over that slide. And first thing we need to figure out is, does that trowel fit the field in the way that I can apply it easily with the equipment that I have? So we want to do at least 3 reps. More is better. 3 is kind of the minimum. Our sprayer is 20 feet wide. Our row spacing is 5 feet wide in the strawberry field, typically. So we're covering 4 rows, but our outer rows are only getting half covered because we're straddling one of those rows. So because those rows are half covered, typically when we spray, we'll come back around and our overlap will cover the other half row. So we don't want to take our measurements, our readings from those outer rows of the treatment area. We want to keep them to the inner 3. So all sampling must be performed on the inner 3. I want to cover the length of the field when I'm doing my application, just because it's easier that way. I don't want to have to shut the sprayer off, go to the other end of the field, then come back around and travel through. So I want to spray the complete length of the field. So therefore I need 36 rows to perform this 3 treatment trial with the 3 reps, covering 4 rows at a time with my sprayer. When I collect my data, I want to take that data from the inner 3. So you can see that, this started out as a fairly simple trial, but all of a sudden I'm up to 36 rows. My goodness, do I have a uniform field with 36 rows in it of all one variety, right? So we want to do this on one variety. So in this fictitious scenario, we're going to proceed. We do have a good field with 36 rows of all one variety. What's on our next slide there? So again, come back to my crayon sketch just to make sure I understand the width of my sprayer, what I'm covering. Each row is 5 feet apart, so 3 rows. So if you're spraying all the time, this stuff, you're the farmer, it's your equipment. But sometimes you have a custom combine guy come in, or you have a Cavendish or Scotian Gold come in with their fertilizer spreader. They're spreading different widths, and things can get quite complicated in a hurry. You just want to sit down and make sure you understand how your treatment's going to be applied, where your wheel traffic is going to be laid, where you're going to collect your data at the end of the day. Just on the next slide there. So how do I make this application practical, right? I have to do this 3 times with 3 treatments. Time, again, is a precious commodity. I'm going to choose a field that's close to the farm, preferably, because I'm going to be running back and forth there quite a bit as I apply the treatments, take the data, and there's usually one thing you forget and you need to go back to the farm for. So choose a field close to the farm. When it's time to make your applications, I'm going to load the tank with the insecticides and fungicides that I'm going to be applying anyway. And I'm going to spray my untreated check strip. So this is how I would do this to make it practical and easy to do. So I'm going to spray my check strip first, my untreated check strip. Then at the other end of the field, once I've done my 3 reps, I'm going to spike the tank with the correct amount of treatment number 2 based on the spray volume that I have left in the tank and the number of acres I want to cover. So I'm going to put the chemical into the tank. I'm going to make a phone call or do something else while that agitates. And before I start treating treatment number 2, I'm going to prime my boom. So now I got the product that I'm trying to test out to the ends of my booms, and I'm good to go. So I'm going to then apply treatment 2 to all of the reps. And then I'm going to go down the field and I'm going to spray my tank out in another field. So now I've left that field, but I'm still getting my work done, right? So I'm going to finish spraying the tank in another field. I'm going to come back to the farm. reload with my same insecticides, fungicides, and treatment 3 to finish spraying the treatment on the 3 strips, the 3 reps. And I'm going to finish out spraying the rest of the field. And then I'm going to continue on spraying the rest of the crop across the farm. So in that way, I'm not spraying half tanks. And what do you do with the part tank that's left over? I'm getting my work done, and I don't have to rinse out in between treatments in this scenario. So next slide. So the other thing that we didn't think about was the randomization of the plot layout. So I want to place my treatments across that field in a random way so that I'm not favoring one treatment over the other. And one of the ways I can do this is I can number the treatments, in this case 1, 2, 3, instead of referring to them as the names. And then I can go on the internet and in this case, get a random number generator. So my minimum number is 1, my maximum number is 3. Every time I hit generate, it'll give me a random number between those 2 mins and maxes. This is a high-tech way to do it. You're really doing a simple job. In the good old days, you just had the numbers 1 to 3 written on a piece of paper, threw them out of the hat, and you drew them out randomly, right? Because we don't have a lot of treatments, some of those treatments are going to run next to each other, and that's okay. It's randomized. It's going to happen. It's going to happen more often when you have fewer treatments, and that's okay. We still need them randomized in order to run our statistics later on. Next slide. The other thing we want to think about and have prepared in the off season is our data sheet. So how are we going to organize the data as it comes in? I find, we all get busy in season, and we'll just take if we don't have the data sheet, we'll just take a random piece of paper. Nothing gets filed properly. And when you go to look at the data in the fall period, probably by the time you get at it, you have no idea where you left that paper. You're missing half your data, and you can't manipulate it in the way you want to anyway. The other thing a good, well-organized data sheet is going to do for you is remind you about what's coming ahead, right? So as you're taking that initial yield, this data sheet is also reminding you that, okay, in a few days' time, I have to do the powdery mildew rating, and I can't forget about that. And oh yes, we got to do the shelf life as well. So it helps to remind you, keep you organized, keep your data together. So again, this is a fictitious trial, so this data is all made up. But it also helps that as I'm filling out the sheet, the things are adding up for me, and right away I can have the average for the treatment. I can have the average plot yield for the trial, and I can see, is this data making sense as we go, and maybe I can pick up some mistakes and correct them along the way. If we get into more complicated trials, is my units all the same? Is my data tight? So just right away, by looking at this data sheet, I can see that the treatments 2 and 3 are out yielding the average plot yield for the trial. So we're kind of hopeful that things are working out in favor of our treatments right away, but that can be very misleading. And we'll see that as we go through the stats. I always say when somebody asks me, how was your hunting season? How big was your deer? I always say, well, it's about average. It's about average. So averages cover up a lot of details. Anyway, next slide there, Caitlin.
Yeah, so I'm going to take over here for a little bit and talk about my fictitious scenario, which is interseeding a cover crop into corn. So I'm interested in trying this, and my big question is it going to reduce my yield? Because obviously that's something that I don't want. I can see the long-term benefits of the practice, but I want to be able to do it in a way that I'm not reducing my yield. So my hypothesis for this is that no, interseeding a cover crop into my corn is not going to reduce the yield. And the data I'm going to collect to support this is yield, of course, but I'm also going to look at ground cover after harvest, because with my cover crop, I really want to see if I'm going to get that a good benefit of having the winter ground cover after harvest. So here's, I'm going to show you a couple different experimental designs. Like Sunny mentioned earlier, replication and randomization are really important, but sometimes it just doesn't make sense to do the randomization part of it, but you can still do the replication part. So here I've just split my field in two. One is with the cover crop and one is without. But within that, I'm going to make sure that I take at least 3 separate measurements. And so those are going to act as my replicates, even though I'm not going to be able to randomize it. This is the exact same field, exact same treatments, but these ones are randomized as well. So it's a little bit more work because you have to mark out not just the split down half the field, but you have to mark out every single strip that you do, because it's going to be something a little different. But you're still going to get those same 3 measurements. This is where you really want to have a nice uniform field, so that so that if you are just doing the split in 2 and taking 3 measurements from within that one side of the field isn't a lot wetter, say, than the other. So for my specific field, I know that the lower part of the field tends to be a little wet, so I want to avoid that with my treatments. And also the right side along the tree line gets a little shady in the afternoon. So I want to think about that when I'm collecting data, and hopefully I can keep my treatments away from that so that it's not influencing the data. Looking at the equipment I'm going to use a 4-wheeler mounted broadcast spreader, and it has an 18-foot spread pattern on it. So if my combine has a 30-foot header, I know that I'm going to have to do 2 passes with my broadcast spreader in order to have enough area for my combine to be able to get a strip down all in one treatment. And that's also going to give me a little bit of buffer room on the edge. So those are going to be the edges that we're not going to harvest initially. We're going to take a nice clean swath down the center, and then we can clean it up after we've collected those yield numbers. The other thing is to be conscious of bias. So it's not so much when you're getting a hard number like yield, but if you're looking at some of these more objective ratings, whether that's a disease or in this case, it's going to be my cover crop ground coverage. It's really easy to be walking along and say, okay, I'm going to measure here. And subconsciously, you're like, I'm going to measure here because it looks really good. And you want to get you want to get a difference. You want to get an interesting reading. So if you can, it's important to take steps to avoid that bias. One thing that I do if I'm doing, say, a population count or something like that, I know I'm going to take 3 population counts within one treatment. And I'm going to start at the edge of the field and I'm going to walk 50 steps. And that's where I'm going to do my population count. And that way I'm just hopefully counteracting a little bit of that natural bias that I might have otherwise. Another thing would be if there's a phone app that might be able to help you with that. So take one of those objective or subjective ratings. And if there's something that can help you do that and give you a hard numerical number or piece of data, then that might be a really good option. So in my scenario, I am going to use an app. I'm going to use this app called Canopio. And it was designed by Oklahoma State University. And it gives you a measurement for percent vegetative cover. So you can see, it's a little hard to see on the phone screen there, but you take basically just a picture of the ground in the app, and it shows the green vegetation as white pixels and anything else, so your bare ground, as black. And then it's going to turn that into a percentage for you. So you could plan to do that at several points throughout the field and then average them, because you're not going to be able to look obviously at the whole treatment. So if you did a few different points within that one treatment, then you could get kind of an average number for ground cover. And with this too, you want to make sure that you're doing it the same way every time, so holding it at the same level and things like that. So I've gone through, season's over, and I've collected my data here. And just looking at it, I've got my yield in tons per acre for my cover cropped area and my non-cover cropped area. And then I've got the percent ground coverage for my cover cropped area and my non-cover cropped area. And you can see right away, the yield numbers look pretty similar. And there's a bigger gap between my ground coverage numbers. But the thing with statistics is that the numbers can be really close together, but still potentially be significant. So it's really important to go through the process of doing the statistics in order to find that out. And this is why replications are important. Sunny mentioned it earlier, but I'll just reinforce it again. You want to try to counteract any variability within the field, and replicates are the way to do that. It's going to allow you to compare your data a little bit more objectively and show whether the difference is significant. So that's a consistent difference or a vast difference, or if it's insignificant. So the data may not be consistent, so you may not be able to draw a proper conclusion from that, or there may be no real difference between treatments. I want to preface this by saying that statistics can get really complicated really quickly, and that is not at all of our purpose here today. We just want to be able to provide a couple of tools that will help you get that, the confidence in the data that you're collecting. It would be really lovely if there was just an app that you could plug in all your numbers to and it would spit out some statistics for you. And we looked, and we could not find one anywhere. So if you know of something like that, please let us know, because we would love to use it. But a couple of things that are fairly accessible, a lot of people have access to Microsoft Excel, and there's actually a free plugin that you can get for that. It's super easy to download, and there are some really good YouTube tutorials on how to use that, which I think we're going to try to pop in the chat. Some other options would be hand calculations. And again, there's some instructions for that, which I will go through and post a link for that as well. Or your other option could be to partner with somebody who can help you with the stats. So that could be, a university or a researcher that maybe it's your favorite perennial specialist might be able to help you out with that. Something like that. So I'm going to run through this quickly. Bear with me, but we are going to post the link to a really good publication on how to conduct research on your farm or ranch that has the instructions for this method of calculating statistics. So this table, it just takes my data, and this is the template that I am using from that publication. And it just lays everything out so that I'm going to be able to get all of the numbers that I need in order to perform my statistics. So I've got I've got 4 blocks or 4 reps, and I've got my cover crop, the yield from the cover crop area, and the yield from the no cover crop area. We're just going to subtract one from the other for this column and to get the actual difference. And then we're going to average it. And the average is our average difference between the two treatments. The next step is to, this next column, is we're just going to subtract, we're going to take the actual difference and subtract the average difference. That might be a negative number. That's fine, because in the last column, we're going to square it. And when you multiply a negative number by another negative number, it results in a positive number. So we've got all those numbers, and we're going to use them to get the different values that we need for our statistics. So adding up column 6 is going to give us our sum of squares, which is 0.06. Then we're going to subtract 1 from the number of blocks to get the degrees of freedom. So 4 minus 1 equals 3. Then we're going to divide our sum of squares by the degrees of freedom to get the variance. So our variance here is 0.02. Then we'll divide the variance by the number of blocks to get the variance of means. So that's going to come out at 0.005. Then we will calculate the square root of the variance of the means, and that gives us the standard error, which is 0.07. So this next step here, I'm going to pull another table from that publication, and what we want here is to select a t-value, and that's basically our confidence level. So we want to be really sure that the data that we're collecting is significant. So we're going to use a 95% confidence level. We've got 4 blocks, so our t-value here is 3.18. So we're going to multiply our standard error by 3.18, and this gives us the least significant difference. So this is the value where it has to be at least that much difference in order to be significant. So we look at that. We're going to compare that to our average in column 4, which is a 0.1, and our least significant difference, is 0.22. So our actual average difference is less than that. So we conclude that there is no difference between our treatments. No significant differences. I'm not going to go through all of this again with the cover crop gram cover, but just look at the last numbers here. We've got our least significant difference of 11.92 and our average difference of 56.25. And so that is definitely a significant relationship. So I will toss back over to Sunny now to talk a little bit about his results.
Thanks, Caitlin. So that was some pretty heavy number stuff there. Make sure you check out the YouTube videos if you ever get into analyzing statistics on your on-farm trial, or just reach out to us and we can walk you through it. Those YouTube videos were excellent. They weren't long, but they were the right pace that you could follow along and work the numbers yourself. So using the same data that I showed you before, put it through the statistical analysis. Initially, I said, looking at the averages, wow, these treatments look pretty good. But when we run the statistics on them and the data did look tight, initially, lo and behold, there is no yield difference between treatments 1 and 2 in our fictitious trial here. So then we can conclude that treatment 2 does not give us a difference in yield, an increase in yield. There is no yield difference between treatments 2 and 3. So between the 2 chemicals that we were trialing, there was no yield difference or increase, but there was a yield difference between no treatment and one of the chemicals that we tried. So that's fairly interesting. So between the two chemicals, no difference, but between untreated and treatment 3, we did get a difference. So sometimes those averages can lead you down the wrong path. Next slide there, and I think we can skip over that slide, just looking at the shelf life. So, oftentimes we'll go through this whole process. We'll come up with a little bit of a yield increase from the treatment. We're thinking fantastic, but does it pay for itself? Is it worth doing if we're not even going to pay for the cost of the material, or if we can find another place to invest our money on farm that's going to give us a better return, right? So I think at the end of the day, we have to make sure that we're putting some numbers to this and see if we're coming ahead by doing the practices that we're doing. So in this theoretical case, a jug of Silical Max is about $120 for 10 liters. I have my units wrong there. So we break that down. What does it cost per acre? We're applying it at 1.6 liters per acre. There were 3 applications. So our total cost of treatment is $57.60 an acre. So that doesn't include our application costs in this case, because we're going to be spraying it anyway, right? We're putting our insecticides, fungicides, just putting this on top of a treatment that we're already doing. So I didn't put the cost of the spray trip in there in this case. So next slide. So we know what the cost of the treatment is. So now I have to figure out what is the return? How much money are we bringing in from putting that treatment on? Our increase in yield showed us an average of 2.2 boxes per 10 feet. So there are 8,712 linear foot of row in an acre. So then we have 1,916 more boxes per acre in treatment 3 at a cost of $2.50 a box. For strawberries, and people are going to think, oh, it's a pretty cheap box of strawberries, but I didn't include the picking cost in there, right? Because we still have to incur that cost. If we didn't have that extra yield, we wouldn't have that cost. So I set my my price at $2.50 per box. So that gives me an extra $3,832 per acre, or a return on investment of 1 to 66. So next slide there. Yeah, so that just goes through the calculation. So for every dollar I spend on the Silical Max, I'm getting $66 back, which, you don't have to be a genius to figure out that, okay, this treatment is going to make you money. And we often see that in hort crops where we have quite a high unit price. But in the field crops, you're not going to necessarily see that kind of return on investment. It may be much smaller. So next slide. So if you're getting a return on investment of 1 to 1 or 1 to 2, would you invest? So for every dollar I spend, I'm getting 2 back. Would you invest? Maybe, maybe not, right? But if it's 1 to 3 or 1 to 4, well, that's a much better investment. Am I going to get that investment back every time I make that investment? Maybe not if you have a ratio of 1 to 1 or 1 to 2, but if you get up to 1 to 4 or better, then things look much better in your favor. Next slide. So as we were talking, we put a bunch of links in the chat of resources that you can look through on your own. That'll take you step by step on different considerations on how to put a trial together on your own farm. If you want to take a screenshot of all of those resources, we have them listed here, and you can keep them for the future. Again, those YouTube videos on how to do simple stats are excellent, and explain it in very simple terms, and you're able to follow them through each step. So they were a great resource.